Welcome to Okie Flora. I'm Gus, and I will be joined in this video by Jordan G with All Tomorrow's Prairies. In this video, we're going to be surfing some scree, hanging off cliffs, and lurking through canyons in search of the mysterious ferns of the Arbuckle Uplift in Oklahoma. Why the Arbuckles, you may ask? Many ferns, especially xeric or dryland ferns, just like this Astrolepis and this Pellia, can't take much competition and are pioneer species of areas with very thin soil and exposed rock, which this area has tons of, including limestone, rhyolite, and ancient granite. Generally, many ferns have a special affinity for certain rock types due to their chemical makeups. The reason is often a mystery, as in nature there are always exceptions to every rule. Let's take a look at how this area was formed. During the Cambrian period, a large-scale faulting event formed a large rift valley, which created a shallow inland sea during the Ordovician, where hundreds, if not thousands, of feet of limestone was deposited on 1.35 billion-year-old granite, which is now the oldest exposed rock in Oklahoma. How did these rocks in a rift valley get to become mountains? In the Permian era, the earth thrusted upward in an uplift event known as the Arbuckle orogeny. This created a huge underground aquifer, lending to springs, which some of the ferns need due to their consistent moisture. On the surface, millions of subsequent years of erosion have left us with a topographically diverse landscape with a plethora of different rock outcrops. Because of this, the Arbuckle region has become a hotspot of fern diversity with upwards of 27 species. Let's get into it. Asplenium resiliens, or the black stem spleenwort. This one's cool. This is, of the aspleniums, most of them like more wet areas. This one is apomictic, so that means it doesn't have sex, basically. It just clones itself, essentially. And it can take drier conditions than most aspleniums. So as you'll see it growing on, well, right here's just a limestone rock wall, north facing. Its leaflets are almost always opposite. See how they're opposite? Some of the lookalikes have alternate leaflets. And then they're also, how it connects to the stem, the black stem, hence the common name black stem spleenwort, is auriculate, which means it's like an ear. So you see how each one connects like an ear does to your head, right? Each one of the, you can kind of see it more on this side. See that? And grows in really dry areas, almost always on limestone too.
Gorgeous, man.
There's only one spot in the state I think it grows off of limestone. This is Pellia atropurpurea, the purple-stinned cliffbrake. This is also like Asplenium resiliens. This one's apomictic, so it doesn't engage in sex. Every single individual is a clone. It has these hairy-looking stems. That's how to determine it from... In the Midwest, you have another species called Pellia glabella, and it has glabrate stems. So there's not... You can see the stems are just covered in little tiny hairs. Almost impossible to see, but tiny little hairs. It looks like frost on the stem, basically. And these guys also prefer limestone, although I've seen them on granite, sandstone. I've seen them on rhyolite as well. But they prefer limestone, and when on limestone, especially in a kind of shaded, moist area, you'll get to where there's hundreds of them. Absolutely hundreds, because they just clone and clone and clone. And these guys are in the Pteridaceae, the subfamily Chilanthodea. So those are the xeric ferns. Xeric meaning really dry areas. So these guys can actually, you see how this leaf is almost dried out? Their leaves, these ones are a better option. See how the ends of this frond, these leaves are dried out, but they're still green. If it rains good enough and it gets moist enough, those dead leaves, they're not dead yet, will actually rehydrate and become photosynthetic again. Now once they get brown like this, like these are dead leaflets, right? But if they're still green and dried out, they can rehydrate, so they can go dormant for a drought and then rehydrate whenever conditions get better.
So if the brown leaflets fall off, is it still able to sprout from the base, or is it basically done for?
That frond is basically, see how this frond still has some leaflets down here?
Gotcha. So but the plant is fine.
Plant's fine, yeah. It can lose fronds if like the drought's like a year and a half. I've seen the drought be so long that it just basically dies back to the ground. Even these ones will turn brown and die.
Yeah.
And then it just waits for it to be better. If it does get better, changing climate. Like here's an Asplenium resiliens right next to it. and this one is dried out. If it rained really good, everything except for these brown leaflets would rehydrate just like that.
Yeah.
It would turn right back to normal, start photosynthesizing again. Really cool mechanisms in how that works. All right.
Yeah.
This is Woodsia obtusa, or the blunt Woodsia. Forgot that common name. Thank you, Jordan. Now, this is the most common fern-looking fern in Oklahoma. We get blunt Woodsia over basically the entire state except the Panhandle. Panhandle, we get a few different species of Woodsia from out west. Those are some special species. But most of Oklahoma, you have the blunt Woodsia. And it's called that because it has blunt leaflets. They're not very pointed. It can't really desiccate and rehydrate, so this frond is pretty much done. Unlike your xeric fern members. But it can grow in really dry areas. It just dies back to the ground and has a good enough of a rhizome to come back up. But yeah, that's the blunt Woodsia. Out of the last few species we've looked at, this is the only one that actually has sex. It doesn't perform apomixis, is what it's called in ferns. And it should be making some spores pretty soon. All these fronds are pretty new though. You gotta have an older frond for it to actually be mature enough for spores. And there's actually two subspecies in Oklahoma. There's subspecies obtusa and subspecies occidentalis, meaning west. Subspecies occidentalis can take drier areas and it forms more mats. So if you've seen it in the Wichita Mountains, that's subspecies occidentalis, and it forms these big mats.
That's
Versus
cool.
this one, this is the typical. This is the powdery cloak fern, Argyrochosma deobata. This guy is endemic to Texas, Kansas, Oklahoma, Missouri. I think it gets into Illinois, and it's almost always on limestone. Pretty much, I think there's one spot I know of it on sandstone, but it's a gray sandstone with a bunch of calcium, so you know, a high calcium rich sandstone. This one's really cool if you look at the bottom of these bad boys. I don't know if you can see it.
Yeah,
See the bottom. It's the reason they call it powdery cloak fern.
I'll get up closer in a minute.
Because the bottom of those, it has this white waxy farina. And what that does, this genus is more in like the Southwest, down into Mexico. It gets really species rich. This is the only member of this genus we get here in Oklahoma. But as you can see, dude, the foliage, blue as hell. It's bipinnate, so it's pinnate once and then pinnate again. And it actually looks like tripinnate as well. This is one of my favorite ferns. It always grows straight out of rock. Most of the time on the north face of a cliff. Right now we're on the south face, but as you can see over there, we're pretty much shaded by the hill on this side.
Yeah.
It's really cool. You can look up there, you see just that crack where the water seeps down through the rock. They're just covering that crack.
Yeah, no
And then
kidding.
in this hole right here, there's, whoa, okay. In this timber, in this hole, there's a shit ton on the north side of this cliff.
Cool, man. Beautiful little guys, man.
Yeah, this one I only know of like 4 places in the Arbuckles it grows.
Really?
Here, the other rock wall just north of here, it's a little bit smaller than this one. And it's not on the side of a cliff. Like it's just the rock wall comes out of the ground, which is nice.
Slick.
Yeah, usually this is covered. Man, be careful, my man.
We're recording, dude. We're live. We're live.
Live action.
Oh, wow. Yeah, these are way different.
Dude, I've never been in here, dude. Never. I'm serious. Usually there's. So right now we are under a waterfall. This normally would have water flowing all over it, misting all these guys. It's still wet enough to support these guys. These are some maidenhair ferns, Adiantum capillus veneris. These guys are in the Pteridaceae, the like dry fern family, but they're in a different subfamily. These are the Vitarioideae. These guys need a little bit more moisture. This is the southern maidenhair, so it's more the southern United States. The desert Southwest, surprisingly, has a shit ton of this. Anywhere dry desert, got a big valley canyon. If it's wet enough, you'll have this species. The Caprock Canyons, there's a place called Fern Cave out by Amarillo that has these guys. I think there's some of these guys out at like Death Valley National Park, all over the West. The farthest north place it gets is really cold. There's this hot spring in Canada, and it would be too cold for this species, but they grow around the hot spring, and that provides them enough warmth to actually grow there in Canada. So it's a cool fern. It's not just in the US. This species is pretty much worldwide, but there's different forms. The ones on like sandstone look different than limestone. So there's some splitters that want to split it up, but northern maidenhair or southern maidenhair works for now.
And we're on limestone now.
We're on lime. This is actually a travertine. So this is not your limestone bedrock. This would be redeposited by the waterfall that's usually right over us. This is like, look up there. See all those, you got stalactites kind of forming, and then just tons of that maidenhair right there. Yeah, and we'd normally be, this is normally an inaccessible spot. The winter drought has it very accessible, and the flow is barely any.
It is sporing really nicely.
Yeah, you can see those. That's a characteristic of the Pteridaceae. They have indusium is the little felt-like covering that covers where the spores are made. But Pteridaceae has something called false indusium. So instead of actually having the covering of the spores, the end of the leaf will come down and cover the spores like that. You can kind of see that. Let's just take a look. All right, see how the end of those leaves folds over? Yep. And then the spores are inside of there. So that protects the spores from, I mean, you would assume dry conditions. And then they don't actually have to make an indusium. All they have to do is fold over the edge of that leaf. And everything in the Pteridaceae pretty much does that.
Wow. These are incredible.
All right, this is another species of Myriopteris here in Oklahoma. May or may not, probably our rarest Myriopteris. It's this one's endemic to the Edwards Plateau, the eastern part of the Edwards Plateau and the Arbuckle Mountains. This is the rough lip fern right here. The top surface has these rough hairs, like really scabbard hairs. Now this one is not apomictic. It actually, despite growing in really dry areas, does engage in sex with the gametophytes. Now, this species used to be one species, the rough lip fern Myriopteris scabra. The more eastern ones are actually polyploid. They have 4 sets of genomes instead of 2. So the ones that only have 2 sets of genomes, those are Myriopteris scabra still. And then Michael Wyndham's lab over at Duke University discovered that these ones are actually polyploid, 4 sets of chromosomes. And so these ones got renamed to Myriopteris gruzier after another person, you know. Eponyms, that's how we do it. So yeah, Myriopteris scabra.
South facing,
limestone cliff. In the summertime, the sun's baking this for what?
All day.
16 hours a day on the solstice.
Yeah.
You know, it could get 150 degrees in these rocks, and these guys are living it up.
Right next to,
see,
yeah,
come with me over here. They usually grow in these like cracks. See that? So all along this base you got them growing. A lot of them are really dried out right now because we're in a winter drought. Once you get in the shade there, that one actually has some real fronds on it. See that back in there?
Yeah.
Some better ones.
Those look good.
And then if you look right down here, they'll also grow in the talus and the scree right below the rock.
Nice. Yeah, I'll get that. Cannot see this thing. They're very pretty.
So the ones that look the best are actually getting a little shade.
Yeah.
Now this is limestone, but this is a conglomerate limestone. So what it is this is formed from an alluvial event at some point where all these pebbles of limestone washed down here and got cemented with some red clay. So when you look at this substrate, you can see that red clay and all those just rocks in it, the conglomerate limestone. Did these on a spring day when it's been raining.
Gorgeous.
Water, you can see how it seeps down these cracks.
Yeah.
You can see why it's in those specific cracks too, you know what I mean?
Yeah, definitely conglomerate, man.
Yeah. I think it's called Frank's conglomerate is the...
It's a heavy flow.
Yeah, for sure.
Growing, so yeah, these Myriopteris growing alongside
in the cliff.
Alongside Coreopsis lanceolata, yucca, what's the yucca?
Probably Yucca arkansana.
Lots of purple green springletop, basket flowers.
There's some Texas Indian mallow up there, Abutilon fruticosum.
Nice, yeah.
It's a native mallow. Here's some seep muhly grass. It generally prefers seeps, but as you can see, we're on the side of a pretty dry ass cliff. But like I said, in the spring, this is all karst, so you get seeps coming out of here. The difference in hydrology between the spring and then the dry winter is absurd out here. This is probably the most, if not top 5 most drought adapted ferns in the state of Oklahoma. Close. This is one of the Astrolepis species, or cloak fern. Astro meaning star, lepis meaning scale. So it looks kind of bluish and hairy. If you zoom really close in there, each one of those is a tiny scale, and they're the shape of a little star. So that's where it gets the genus name Astrolepis. This specific one is Astrolepis integerrima, or the hybrid scale cloak fern, because this one originated as a hybrid of 2 different species, a known species and I think an unknown species. This one is apomictic, so it doesn't have sex. Everyone's identical clone. This one's actually looking pretty good for the time of year we are. These fronds they can get up to 2.5 feet long if it's looking really good. Now, when they aren't doing as good, a little bit of drought, something like that, we get to this position. So these fronds are curled up and dry, but those scales help maintain as much moisture by maintaining a boundary layer, covered in scales, keeping that moisture in. But even when that moisture does get lost, sometimes that happens. We don't want our plant to die if it's in a bad drought. So what these plants do is they dry up, curl up, wait for the next rain. If it's in time enough, they don't actually die, and these curled up fronds can actually rehydrate and go right back to photosynthesis within minutes, actually. Super quick. And as you can see, this one's growing, look at this, Opuntia right here.
Yeah,
Ferns growing literally right next to cacti.
Ferns and cacti.
Same exact habitat. Yeah, this is one of my favorite ferns in the state of Oklahoma.
Basically south facing again too.
Basically south facing. It's mostly a southwestern species. This same species grows with like saguaros and shit in the Colorado deserts. Joshua trees, Sonoran's saguaros, right? Right.
I think so.
But this species grows out there, driest spots in the country pretty much. It's taking it really well.
Man, they are.
They're amazing.
Very gorgeous.
That blue color. Super scaly. Lighting's gonna be shit, but this is a pretty big clump. So this might, they're all one individual because they're an asexual species. But where you get old ass clumps, what it does is they clump out, and then in the center it makes dirt basically. So this could be like one individual that's shit.
Very old.
Decades old, yeah.
With Sido's grandma.
Sido's grandma taking over in the center. Yeah.
That's really cool.
Yeah. Some Coreopsis.
Man, they are so stiff.
Oh yeah.
The fronds.
If you think some ferns use like a waxy farina like our Gyrochosma, right?
Right.
Some ferns use a shit ton of hairs and scales. This one does both,
That's crazy.
So maybe one of this guy's parents, it's Astrolepis sinuata, the wavy scale cloak fern, has way less scales on it. It's more adapted to a more moist area. It's not as far southwest of a species as this. But that one has way less scales, so you can kind of see the waxy surface. This, it's just covered in scales, you know? Just built to survive 16 hours of 100-degree Oklahoma sun, or 115-degree Guadalupe Mountains, Big Bend, Texas sun, you know? All right, this is a really cool fern. Another species of Myriopteris. Look at that bad boy. Right in that limestone crack. Super dry, but its roots are getting down there in that limestone where it gets wet. This is Myriopteris gracilis, or fee's lip fern. The reason it's called that is because it used to be in a different genus, Chilanthes, and it was named after a dude named Fee, so it was Chilanthes feei. And when they changed the name to Myriopteris, it didn't get the same feei specific epithet. It got gracilis, so the common name is still fee's lip fern, but the scientific is gracilis. It's got densely hairy on the top side of those leaves. Then on the bottom side, even more densely hairy. There's these red, tiny hairs that cover the whole thing. And they don't get really much. This is one of our smaller species of Myriopteris. This is about the biggest they get. And they love growing just straight out of limestone. I'm thinking there's a couple places it grows on granite, and then it also really enjoys growing out of gypsum as well. So it just likes, I think it just likes that calcium that it can get. There's a whole bunch right up there just covering this cliff in most of these cracks. So that's Myriopteris gracilis. Got those hairs to help with the heat, the dryness. Hell, this species grows in the desert southwest. It grows on a canyon wall right next to some saguaros. But it also gets here into Oklahoma on a south-facing limestone rock wall. Amazing. I love some ferns.
With prickly pears.
Prickly pears right up there.
Side oats grandma. What's that? Springle top.
The green sprangle top, the
Yeah.
second termum up there. This is the resurrection fern growing. It's usually an epiphyte. So down in the southeastern US, it grows on the top of trees, big ass oak trees with tons of moss. Here it's growing epipatrically, and petra meaning rock, so it's growing on the rock. We haven't had a good rain in a while. How can I tell? These guys are completely dried up. Are they dead? No, no, no. You get another good ass rain, soak this son of a. These guys will be open and photosynthesizing in about an hour or two. Now, despite not being a desert fern or a xeric fern, they do the same shit. Just that convergent evolution, being able to grow on a really harsh place, like the side of a rock or on top of a tree. And you gotta be hedging your bets for when the droughts come. You can't just be relying on the little bit of water that soaks down from the top of the tree or on top of the rocks. You gotta be able to go dormant. Yeah, that's a cool one. Resurrection fern, Pleopeltis michociana, named after old Michaud. Another species of cliff break fern, also known as Pellia. This is Pellia wrightiana, Wright's cliff break. This is also another species of fern that you can find growing literally at the base of a saguaro cactus down in the southwest deserts. The differences between this and the purple stem cliff break, you see the tips of those leaves? They have mucronate leaf tips, just like your red oaks do, little tiny mucronate leaf tips. And as you can see, the stems, instead of being a dark purple, they're a reddish brown, and they're completely hairless. I don't know if you know the Pelliacho purpurea, full of hairs. This is completely hairless. Despite being more of a desert southwest and drought-tolerant species, this one is sexual, while Pelliacho purpurea is apomictic. So it's a little weird. Sometimes nature doesn't follow the rules we set, and that's, you know, part of biology. As you can see, look along this crack. A few years ago, this was full of probably about 50 of them. Just the droughts have kind of hurt them pretty bad, but these few are still surviving. Cool ass fern. There's a few disjunctions. There's a few places in Arkansas it grows on really high quality glades. It grows in Georgia at that Lake Jocassee, where there's that huge granite wall that they made 30 years ago. It grows there. Supposedly, most likely the spores traveled there on a jet stream. This one's cooler though because it's sexual. 2 spores had to fly there on a jet stream.
Wow.
Right? So, I mean, I think a gametophyte could have sex with itself, but generally you need that diversity.
Right.
So yeah, this is a badass fern.
And what's this guy?
Oh, that's also the
Same
pellia.
guy?
That's just the brand new growth.
Yeah, it's
Under here though, these guys, that's a woodsia.
Yeah.
Common woodsia. So that's not
Cool.
the same guy. So yeah, pellia. This is the last species of Myriopteris in the Arbuckles, Myriopteris alabamensis, the Alabama lip fern. This is pretty dang rare in Oklahoma, Ozarks, Arbuckles, and then like 1 or 2 spots in the Ouachita Mountains. This is related to Myriopteris scabra, but if you look close at these are completely hairless on the top and the bottom. And so if you think hairs are to help protect something from harsh, dry environments, that kind of tells you that this one grows in more moist, protected environments than other species of lip fern or Myriopteris. And you'd be right. This one grows in more moist areas, the eastern U.S., northeastern U.S., and it loves limestone. This is, if this is like out east, in the Appalachians, they call them rock houses, because they're a refugium for the last ice age's flora when it was a lot colder. That's what this is, basically, you know? We're pretty far out of this species' contiguous range, spotty. Even in Oklahoma, it's usually really micro, up in the Ozarks, north-facing bluffs, same kind of microhabitat. But this is the most extreme example. We're 40 feet in a crack that's maybe, 10 foot wide, 12 foot up there. No sun. And if the climate keeps going, this is a refugium from the ice age. The climate keeps getting warmer. It won't expand. They won't get this big. The actual microclimate they can occur in is smaller. Not only that, when I came here, get over here. You see all the little babies in there?
Yeah.
Imagine if all those babies were fully grown. That's how many when I first saw this place several years ago. Just with the droughts and stuff, they're not doing very good. Now it does look like this spring they were able to come back, or spores, because this one would probably be a baby from spore, versus this one would be a baby. That one hadn't even rooted yet. Look at that. Cool. So that's why it's called Splenium rhizophyllum. It's walking along.
Yeah, hold that right there. Leaf tip turns to root tip.
Leaf tip, root, brand new leaf. Right there too. Spread. Like genetic individuals in here, way less than actual individuals. Probably, I'd give it probably a dozen, 2 dozen actual individuals. Yeah, look at that. Crazy. Even right here.
Yeah.
Like the amount of leaves through here too. You don't know how many have been covered up.
Right.
I remember first coming here, there was some more in here actually. So we've kind of explored the fern flora of the Arbuckle Mountains here in south central Oklahoma. And even in the winter, you can see a huge diversity of these ferns here in the state. We've seen 5 species of Myriopteris, the lip ferns, right? 5? Yep, 5 species. 3 species of Asplenium, maybe 4 if we go to another property. Species of Pellia, Argyrochosma. What is that? That's like 10 species. In the Arbuckles, there's about 12 to 15. There's some other ones that are actually deciduous. We saw Woodsia, the common fern. Equisetum. We didn't get a video of that, but we'll go back and do that. But yeah, the fern diversity here in the Arbuckles, because you have limestone, you have wet limestone rock shelters for these eastern plants. You have dry ass limestone on the west side of the Arbuckles for those western ferns coming in, and those southern ferns coming up from Texas. The granite, you have western and eastern ferns on the granite. In fact, earlier we talked about Woodsia obtusa. There's 2 different subspecies, right? There's the western one and the eastern one. The eastern one is clump forming, the western one's mat forming. On the granite part of the Arbuckles is one of the very few places where those overlap. So you actually have both subspecies of Woodsia obtusa in the granite part of the Arbuckles. Just a huge fern diversity. And, these are reliant on, this staying moist enough and cool enough. Even this deep, if it gets 20 degrees warmer up there, it might only get 5 degrees warmer down here, but that might just be enough to these over. Even your western species, they're used to a decent amount of rain, but when we just don't have that rain for a long time, they're used to maybe 100, 120 degrees, but maybe not 115, 130 on the rock. And those rocks can get way over 130 even. They're struggling, and we gotta protect them. We gotta make sure these kind of places are protected. This would be an amazing place to protect for perpetuity.